Writing an inheritance program. Consider this scenario. You're working for a university that wants you to write a program that will store information about various stakeholders, i.e. students, teachers, staff, etc. How would you go about solving this? Let's start by designing some classes. We have students, teachers, and staff members. They have names, ID, GPA, year, salary, courses, departments, and roles. Once we write the init methods for all of those attributes, we'll have duplicated a lot of work. See the redundancies? Let's make everyone at the school a person object with certain attributes. From there, every person will have more specific attributes unique to each role. The idea is that every class is built off of another class. This is an is-a relationship in inheritance. So a teacher is a person and a student is also a person. Let's create the parent class, class person. Attributes of person class can consist of name, birth date, address, and role. First, we need an init method that sets the attributes for every person. So in this example, we're going to use name, address, and birthday. And so we're going to set those attributes for every person using this init method. Next, create the child class teacher, since a teacher is a person. What information would you want to know about this object? Subject and number of courses. Let's begin with naming the class and some attributes. So here we have teacher inheriting from person. We have our init method, and we're going to send subject and num as arguments to this method. These are all the new attributes of the teacher class. Finally, let's save the arguments sent to the teacher init method into some attributes. Alright, so when we create a teacher, we're actually sending all of these arguments here. See how there's 1, 2, 3, 4, 5 parameters, 3 of which are actually attributes of the parent class, the person class. So the first thing we're going to do is send the 3 attributes from the person class up to that init method using super, the super keyword. Then we're going to save subject and num into attributes in this init method in the teacher class. Remember, when you send arguments to an init method, you have to send the arguments in the correct order. In the case above, the correct way to create a teacher object would look like this. Teacher 1 is our new teacher object, and we're sending biology. That will get saved into this parameter here, subject. 4 will be the number. Rosa Garcia will be name. 123 Main Street, Portland, Oregon will be address. And here we have a little list. 3/15/1983 will be the birthday. Let's create a teacher and make sure our code works. So here is the code from the previous slide where we create our teacher object. Then we want to print our teacher name, address. So here we have Rosa Garcia, our address, print the birthday, and remember the birthday was a list, so we're going to access that first item here with this bracket notation, square bracket notation for 0, because that's index 0. And so we're going to print out the birthday, this is kind of cool, right? We're accessing each element in this list, separating them by slashes, so that the birthday comes out looking like this instead of like a list. And then at the very end it will say teaches how many courses in which subject. Teaches 4 biology courses. Now we're going to add a method to our person class and then use it with a teacher object. First, remove some of the attributes to save space. Below we have our new simplified classes. So we've removed some code just to make it easier. Person now only has name and teacher has a subject. So now a teacher has a name and a subject, a person only has a name. Our new method is sayName, and it prints the person's name. We will put this method in the person class, then create a teacher object to call it. We can successfully call the method from the child class. So here's our method definition in the person class. Here, we call to that person class in our init method just to set the name into that attribute. Then down here, we create a teacher object, and then we can call this method on a teacher object, and it will first look in here to see if there is a method called sayName. There isn't, so the computer will then look up here to see if there's a method called sayName, and there is, so it'll run it. However, what if we want teachers to have their own specific greeting? For example, what if teachers should say, "I am your teacher, blank"? We can override the sayName method in the person class by defining a new function with the same name in the teacher class. So here we have our sayName method in the person class, but now we also have a sayName method in the teacher class. So remember, before I said the computer's first going to look in the teacher class for a sayName method, and now it'll find one. To make it clearer, let's remove even more of the code. Now, each class only has a sayName method. You can see that when we call the sayName method on the teacher object using dot notation, the version of sayName that was defined in the child class was called. We overrode the method from the parent class. So this method will take precedence over that one when we call the method from the teacher object.